Hey everyone! Today we're going to start in chapter 12, which is about forces and motion. Now, motion was heavily talked about in chapter 11 before we went on Christmas break. So now we're going to focus on, well, how do forces affect my motion that I'm seeing? So section 1, we're going to first focus on what is a force and then how does that affect motion. And we're going to hit on a couple types of forces that we can see. So our intro picture shows a guy walking through the rain and he's holding up an umbrella to kind of protect him from the rain pelting on his dress uniform. And it says the wind pushes against the man and his umbrella, and we're going to learn that the push from the wind is considered a force. So what exactly is a force? Well, we're going to define it. A force is a push, such as the rain on the umbrella, or a pull, so you pulling a chair towards you, that acts on any object. So, how do forces affect the motion of an object now? And that's our key question. Just a gentle reminder, key questions often appear on tests as short answers or multiple choice, but you typically do see them. So, how do forces affect motion? Well, if the object is resting, which means that it is not moving, it can actually cause that object to start to move. So it can start to roll or push or move in any way. The other way that it affects an object's motion is if the object is already moving, it can cause it to accelerate. Now, we did go back over what acceleration is, so we have to remember that when you accelerate, you can either change speed by speeding up, or you can slow down. And this also includes a change in direction as well. So, for an example, if you have a ball thrown at you and you take a bat and it hits the ball, pushes it, which is a force, it can cause that ball to go in a different direction, hopefully a home run. So, how exactly do we measure a force? You may have already measured forces already, especially if you have stepped onto a scale. Now, in today's world, we have digital scales, so it tells you the weight of something. But in the past, and some grocery stores still have this, there is something called a spring scale in a grocery store. That is because a lot of fruits are sold by pound, and so people want to know how much are they paying for their fruit. So here is a spring scale, and then it has a little bucket where you would put your fruit. That will weigh this down, and the spring scale will measure how much does that fruit weigh, because weight is a type of force. Here we can see arrows representing this force. Notice that if we have a few oranges, it's not going to have as long of an arrow as having more oranges. And that's because the picture on the left has less force than the picture on the right. We see this on a digital scale as numbers. Here on this scale, we see how far my little arrow goes over. Now, what units do we use for force? Because just like last semester, I'm going to be very specific that you use units. And the unit for force is called a Newton, which is a capital N. It's going to be defined as the 1 kilogram mass to accelerate at a rate of 1 meter per second for each second. So when I say force, it takes into account mass, which is kilograms, and it also takes account acceleration. So remember, mass is a unit for kilogram, and meters per second squared is for acceleration. And then again, Newton is for force. So these two units equal each other. So let's talk about forces. So we already asked, how does forces affect the motion of an object? And there are a couple terms that we're going to introduce here called balanced versus unbalanced forces. So when forces on an object are balanced, which means they are equal, we tend to get a net force of 0. And that's because they kind of cancel each other out. And when they cancel each other out, when we say something is balanced, usually there's no change in the object's motion. However, there's something called an unbalanced force. When it acts on an object, that means one force pushing against the other is a little bit stronger, and it can cause that object to start moving or accelerate or change direction. This brings up the term that we kind of have to define, which is net force. When I say net force, I'm talking about overall all the forces acting on that object when we combine them. So there are a lot of forces in the world, such as gravity or static force or magnetic force. So there are tons of forces. So net force gets an overarching whole picture idea. Just like we learned with like displacement and velocity, typically if forces act in the same direction, we add them together. If forces act in opposite directions, we tend to subtract these from one another. So again, forces add or they can subtract. Note here, if they add together, I get a bigger force in the end. Here they have opposite. Notice my arrow on the left is bigger, which is why this object is eventually going to move to the left. So for example, if here's a little kid and here's a bigger kid, and the bigger kid pushes the little one's probably going to fall back. Now, if we have equal and opposite forces, notice that they are going to cancel, so we get a 0. And so this would be unbalanced force. This is going to be, unbalanced because we have an arrow. And then since this equals 0, we call this a balanced force. Now, balanced forces combine to produce that net force of 0, like we've seen on this slide. And an unlimited number of individual forces can act on it, but if the net force is 0, it's still considered balanced. Another way to look at balanced versus unbalanced is tug of war. So if you have two groups that pull on a rope with equal force, they're going to cancel out, and here they have the same force on each side. This is considered a balanced force, and again, my net force is 0. However, an unbalanced force results when the net force is not equal. So for example, if you have 3 big, strong football players pulling against people who may play golf or maybe not be as strong, that's an unbalanced force. The last thing we're going to hit today is kind of friction. So friction is going to be defined as the force that opposes the motion of objects that touch as they slide past one another. So you've probably had friction whenever you've taken your hands and you've rubbed them together really fast, it produces a heat. And there are 4 main types. There is static friction, sliding friction, rolling friction, and fluid friction. Static friction is the friction that all objects have that are not moving. And typically, static friction is the friction you have to overcome in order to get something to move. So static friction always acts in the direction opposite of the applied force. That means if you are trying to push a dresser to the right, the friction is going to apply against you towards the left because the object doesn't want to move. It's inertia. It wants to stay in one spot. Sliding friction is going to be the force that opposes the direction of the motion as it slides over the surface. So sliding friction, sliding over a surface. One thing to know is sliding friction is less than static. And what that means is once you get an object moving or sliding, it's a lot easier to keep it sliding. So again, if you're trying to move a desk, you have to use way more force to overcome static friction because it's not moving to get it to move. And once it's moving, sliding friction does not require as much force. So again, if we look at a potted tree, static friction, the plotted plant is not moving because if you apply a force this way, it's applying a force back on you. However, once your applied force becomes bigger, notice the arrow, it overcomes this static friction holding it still and it starts to slide, but we're still going to get a little bit of friction down here from the flooring, so we call that sliding. Next, we have rolling friction, and this acts on rolling objects, hence the name. And notice that the force of rolling friction is 100 to 1,000 times less than static or sliding. Think about it. If you're having a hard time moving an object, what do you put on it? Wheels, because rolling friction helps things move a lot easier. So here are ball bearings in the wheels to reduce friction. It helps us slide and move things along without as much force. Think about it. It's a lot easier to move a desk putting it on wheels. It does not take as much force than it does if it was on the ground. And the last type is fluid friction. Fluid friction is actually defined as the motion an object through a fluid. Now, the fluid is going to be defined in a later chapter, but I want you to know it in this chapter. A fluid is something that is a gas or a liquid. So, fluid friction acting on an object moving through air, because air is a gas, is called air resistance. And we've heard that term before. One thing to note is that fluid friction tends to increase if the object is moving faster. And that's because you can feel, like, as you run through the wind, you can feel that resistance pushing against you. And that is the end of part 1. Let me know if you have any questions, and I hope you guys have a great day.